What is up, YouTube? Let's end that jazz. We're back with another JavaScript with Joe. Join us every Wednesday at 4 p.m. Let's do some JavaScript challenges, people. So to those of you that don't know, this is Advent of Code. They do 25 holiday-themed challenges every single year. And you basically collect a couple of stars, try and beat all the challenges. So far, they've been pretty easy. I'm not expecting them to continue to be easy, but at some point we'll probably deal with some more complicated sort of computing topics. I'll probably fail some of the challenges, but that's totally normal. And my goal is to try and beat them all in sort of half an hour for each star or 1 hour for a whole challenge. Is there anything else? I'm going to be obviously doing them in JavaScript and using this site called REPL.it. So you'll be able to see my code at the end of this video there as well. And if you don't already have JavaScript set up, this is a great site to use to just sort of get started writing some JavaScript or Python or whatever it is you want to do. Anything else? I think we're good. Feel free to type in the chat if you have any questions or if you want to correct me when I'm doing something wrong or teach me something new or teach all the viewers something new. But other than that, let's get started, I suppose. Okay, so day 3, binary diagnostic, already sounding a bit more computational than the previous ones. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input. So every one of these will come with a puzzle input, which will normally just be some huge file. So here it is with hundreds of rows of what look like binary digits, but we'll see. Puzzle input consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. So given the following diagnostic report, considering only the first bit, we can see that there are 5 zeros and 7 ones. So I guess we keep a 1 for that first bit. Since the most common bit is 1, the first bit of the gamma rate is 1, the second bit of the number is 0 because there's more zeros than ones. Most common value continues, the 1, 1, 0 respectively, and the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number of those most common values, then we convert that to decimal, and the epsilon rate is calculated a similar way, but rather than the most common, the least common bit is used. So the epsilon rate is... Wow, okay. So it's just the flip of the gamma rate anyway. So we could just flip all those bits. And then we multiply them together to get the power consumption. Okay, that doesn't sound too bad. So to start with, I'll just place these. So almost all of these will require us to read in a text file into arrays, basically. So I'm going to keep the way of reading in the puzzle input just to save us a bit of time. So if I console.log that input out, there we go, we've got all my binary bits. So I'll skip over this basically, but it's using a package called file system. We're creating a variable called input, and it's reading in from that text string. It's splitting by the new lines, which are the enters there, and reading that into what we call a list or an array. And this just means that I can iterate over that list quite easily now without needing to jump into all that. Where should we start with this, really? I mean, we need to get the most common bit from the first character. So I guess we probably need to sort of map this to... Maybe not map it, maybe reduce it down to a count of most common bits, though that sounds kind of pointless as well. I guess let's keep it simple. So let's just see if we can get a list of the first numbers in each array. And actually we do want them as strings as well. So if I wanted to get the first item in this array, I could do that just by saying item input 0, so that will grab the first item or the first element in this list, so it should just give us 0, 0, 1, 0, 0. And if I wanted to grab the first item in that list, because although it's a string, it's also a list, so we can actually just use that notation again and get the first item of the first item. So that should just give us 0. So we can use something like this to iterate over that list and get every single value. So I think the next thing I might do is just print out each one line by line. So let's do a input.for each, I guess, digit. And let's just do console.log. It's not digit, actually, digits. So that will give us each digit line by line like that, instead of in this weird listy format. And then we could get the first digit using 0. So now, to figure out if it's mostly ones or mostly zeros, we could just count the number of ones, or even sum up all of these numbers and just see if that number is greater than or equal to half the number of occurrences. So we could say like our size of the input is input.length. Does that work in JavaScript? Let's see if that's what I'm expecting. Yeah, we get 12. So we're just looking to see if 0 is more than 12, or, well, if that total is more than half of 12. So we could just say, for now, let's just do, oh gosh, I didn't even declare that. Let's do const. Let total for first equals 0, and I'm just going to go, instead of just console logging, I'm going to do total for first plus equals digits 0. So that should be 1, 2, 3, 4, 5, 6, 7. So if we console.log that at the end, total for first, we should get 7. Oh, because they're strings, so it needs to be parseInt, spelt correctly, parseInt. So there we go, we've got 7. And what we should be saying here at the end really is if total for first is greater than 6, that needs to be in brackets for a condition. So if we find more than, it shouldn't be 6 as well actually, it should be the size divided by 2. So if the number of ones is greater than, I guess we could just say in English probably if majority are ones, then we go into this case, .log, well, this position is 1, else it must be 2. This isn't necessarily, sorry, it must be a 0. This isn't necessarily the case. There's a missing case here if the number of ones is equal to the number of zeros, which might be something that pops up in the second part. But for now, that means that, 5 or less are ones, and so this position must also be 0. And then we could start to build up our sort of end string there. So let's say let output equal, and that's just a string. So when I get here, I can do output plus equals 1 as a string, so that'll concatenate onto my empty string. Otherwise, output plus equals 0. So we should just end up with output as a single 1 here. But eventually we can build that up to be the whole thing. So there we go, we've got 7, and because of that we've got a 1. So that's looking good. We probably want, what I'm ending up doing here is I'm going to iterate over the entire list just to get the first character, then over the entire list just to get the second character, over the entire list just to get the third character, when really we could do them all at once. So I could do something like this, though this is feeling a bit silly already. So total for second is that second digit. And to do that, we'll have to have 5 different variables just for this, and in the test case it's even bigger. It's not terrible, but we could probably store these values in a list as well instead of using variables and lose some of that context. Though that might be okay for now. So then we would need, again, a whole nother if statement. Not great. And just using total for first instead. So now I should have 1, 0, I think. Oh, that's not right. Is that right? Should be more zeros for the second position, definitely. So that shouldn't be 7. So somewhere I'm probably using the wrong variable. Oh no, but it got the number there. It's just printing total for first twice. Okay, cool. Okay, so that's building up correct. Already this is becoming a problem. I don't want to write loads of if statements, so I probably, instead of even a notion of total for first, total for second, I'm going to go for something like this. I'm going to have a totals as another list, and now I can use the positions of that list. Can I write to that list? Totals 0, so that's the first position of the list. If I write equals 1, 2, 3, I can just write directly to that list. Can I do totals like the 4th position? So that's 1, 2, 3. Yeah, and it'll create some empty items. Okay. So now instead of doing this, I can do totals 0 plus equals pass int digit 0. So I think I can build up to do that instead. And then now all I need to do is increment this value. I probably write another for loop inside there. So 2 more of these, and that should give me all 5. So now we should have a full totals object, and then again we could iterate through each of those. So we could say totals 0, totals 1, and this totals 0, totals 1. So we should get the same thing now. Oh, we don't know. Okay, so somewhere I can't increment. I imagine at this point I'm doing something like, let's see what totals 5 is. So it's undefined, so I'm saying undefined is equal, can I just write undefined? Yeah. So what happens if I do undefined plus 1? We get not a number. So that's our problem. Probably get around that by, I guess I could just fill them all with zeros, like that. So now instead of going undefined plus 1, undefined plus 0 and erroring, it's going 0 plus 1, 0 plus 0. And because we're not actually checking the number of zeros, we're just counting the number of ones, that doesn't actually impact any of that. So that kind of works. The issue here is now I have to change this based on the length of my inputs, which I also don't like. So I wonder if there's like a zeros function or something in JavaScript. Sorry, I just Googled that on the other computer. Initialize an array of zeros, JavaScript. And there we go, we can do new. So we could do let totals equals a new array, let totals equals new array of length, though I don't want the length, I want the length of an individual input, so I can do, where am I keeping them? Input 0 length would give me everything I need there. So that will give me the length of one of these strings, which should be 5, and I can fill that with zeros. So this total should be identical to this totals now. And let's check that while we're here. So we should just see a list of empty. Oop. There we go. So that's done what I wanted it to do. Create a list of zeros of length of our don't know, binary digit, I suppose. So we don't need these totals anymore. We're still using the size. We don't need this input to be logged. And this could be much improved here. So maybe I'll make a note here to do iterate over totals instead. And we also need to replace these to do iterate over if statements, I suppose. Again, we could go over the totals array to do that instead of what we're doing now. So what I'm going to do in here is again go digits dot for each. So for each digit in digits. And I'll just console log each digit. So what we should see now is a log for each digit in each. Digits dot for each. So digits is a string there, so it needs to be a list. Okay, so it's logging the whole digit, so that split isn't doing what I want it to do. Console.log digits plus digits, and this should be a digit, so I'm just logging some more helpful strings for myself here. So it looks like there's no difference there, so that split isn't doing what I want it to do because I need to give it this. So by default I think that splits on spaces, but I want it just to split all characters. There we go. So now we've got each digit and it's followed by an iteration over each of its digits. So that's just done by these two lines here. So we're splitting that whole list we have at the start into digits, and then we're splitting each of those digits into an individual digit per iteration. We're also going to need the index of that digit, which I believe we can get in for each anyway. So yeah, we need to access the index as well of each loop. So if we just pass another value into that arrow here, we do get the index as well. So the first one will be, as you can see here, the value. The second one will be the index. So then we can go totals index plus equals pass in digits index again. And I think that replaces all of that for us. So we're still getting our 1, 0 as the output, we're still getting our 7 and a 5. That's because we've not done the if statements, but our entire total should actually be correct. So at this point we should be able to console.log totals, and we should see 7, 5 something something. 75875. Do we get that? It doesn't really tell us, but we can count them, though I'm fairly confident that's okay for now. Next, we need to iterate over our totals. So again, another for each could work here, or we could do a map. What should we do? Let's do a map just to make sure we're using a map. So totals.map, and again we can say digits, arrow, and then we decide what gets returned here. So this will overwrite our current array, and then we could join them, I guess, instead of doing what we're doing here. So, and we do need the no, we don't. Totals.map is not digits. Total.map is counts. So for each count, we're going to do this if. We can do better than that. We can do count greater than size divided by 2. And we can return that count. So that will be true or false at the moment. We could actually just convert those true or falses to integers then. Pass int true. True. Oops. It won't convert to 1. Okay, well let's do that. If that's true, then we'll return 1. else we will return a 0. So this is what we call a ternary operator, this question mark. I might have got that backwards, but I believe that will say if this is true, return this one, otherwise return this one. So if I log our totals before and after there, we should have one that's the numbers and one that is 1 or 0s based on whether they're above or below 6. And I have to overwrite totals here like this. No, maybe we should just use our output variable for that. And let's store output. So there we go, 1 0 1 1 0, and we can see there above 6, below 6, above 6, above 6, below 6. So that number's looking good. We can then join that string. So if I do dot join, again with an empty string, it should just turn them all into one character. That's that one. I guess somewhere else we're logging those individual totals and the output. So we don't need these if statements anymore. That's all replaced just by this single map. So convert totals to binary. It doesn't really convert them to binary though. Convert totals to list of binary, I suppose. Maybe if we include that join there, then it converts to our binary. To binary, and then we don't need to join here. Cool. So that is correct for our gamma rate, and we need to convert that to decimal. Maybe let's call that gamma rate. So gamma is output. And then we also need to flip those to create. Oh, that's kind of okay. Let's keep gamma as a list, because then we can just do another map and we can say let epsilon equal gamma.map, and again all we need to do here is flip those digits. So digit, and we can do digit is equal to 1. If it's not equal to 1, we return. If it is equal to 1, we return 0. Otherwise, we return 1. So a much more advanced use of that map and ternary operator immediately, but we can see how that's quite powerful there. So we should have our epsilon array, which should be an inverse of our gamma. So there we go, 1 0 1 1 0 0 1 0 0 1. Looks good. That one's an integer because I returned them as integers here. Is that going to help me? Maybe not. Let's just keep them consistent. Okay, so they're clearly inverse now. I don't really need to see the totals anymore. Pretty happy with that. Flip our bits. And now we need to convert them to decimal and multiply them. There's probably a function we can use to do this very, very quickly. I think that's what I'll use. JavaScript, though we could just use a for loop to build it up as well. Easy peasy. Okay, so let's say gamma equals parseInt. The binary is our current gamma dot join, like that. It might need to be converted to an integer, but let's see. Nope. Same for our epsilon. So 22 and 9, and we've got 22 and 9. So now we just need to multiply them together. So let's do console.log gamma times epsilon. 198, and that is the answer we're expecting for this easier solution. And let's try using the actual puzzle input. So this is our test to see if everything we've done so far is correct. We get a number. I've probably removed too many logs to see if that's actually correct, but it doesn't look very impressive when it just comes out as one number. Binary conversion, and calculate our power consumption. Okay, I'm pretty happy with that. I'll take any obvious refactors from the audience if you see any, but otherwise I'm going to submit this and hope that it's correct. Nope, that's not it. It was... Oh my gosh, that's the right answer. Another star. We got 5 stars. We're a 10th of the way there through Advent of Code. Let's see if part 2 punishes me pretty bad for any corners I might have cut there. So right, we still got another 35 minutes as well, so hopefully this isn't a nightmare, though it does look like one. Okay. Next, you should verify that the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only numbers selected by the bit criteria for the type rating value for which you are searching. Discard numbers which do not match it. If you only have one number left, stop. This is the rating value you are searching for. Okay, this sounds a bit trickier. Otherwise, repeat the process considering the next bit to the right. The bit criteria depends on which type of rating you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in that current bit position. So that's our gamma rate. And keep only the numbers with that bit in that position. If they are equally common, keep the values with 1. So I imagine we're basically looking for the number that is most like our gamma rate. So maybe it will be useful to log out our gammas again. But that's gamma as a decimal number. So let's get our, for now let's just get that gamma rate back. So here, so we're probably looking for the number in our data that's most like this one, starting from left to right. So if we look at that input, it'll be, so it wouldn't be these because of the 0, wouldn't be this because of the second digit, wouldn't be this because of the third digit, wouldn't be this because of the fourth digit, and would be this. So in this case it would be an exact match is what I'm guessing. Let's see if that's what it says. Oh, it doesn't help that everything's in these weird codes. Okay, they're all equal, so to find, keep the number with the 1 in that position. Is that what I did? No, so they say it's that, so I've not understood that fully. To find the oxygen generator rating, determine the most common value in the current bit position, keep only numbers with that bit in the position. If they're equally common, keep values with a 1. But they're not equally common in that first one, were they? Let's do, I need my totals again as well. So they're not equally common there. So why does it give me a 1? To find the CO2 rating, we look at the least common, so we're using the epsilon, and if they're equal, we use that 0, so we need to sort of change the way we're calculating totals for this part. Start with all 12 numbers, consider only the first bit. There are more 1 bits than 0 bits, so we keep only the 7 numbers with 1. Consider the second bit. There are more 0 bits than 1 bits. Okay. So it's recalculating every time. So instead of just comparing to that, we're just checking the first value, and in which case we're deleting these zeros in first value, 0 in first value, 0 in first value. Then we're recalculating this. So are there more zeros or ones here? And in this case, there's more zeros, so it stays 0. So we delete this, this, and this. Then we're recalculating again. In this case, there's more ones, so it happens to line up anyway. In this case, there's still more ones, so it lines up anyway. And then when we get to this point, there's an equal number of zeros and ones. And for the gamma rate, this means that we look for a 1 instead. So we would take this one, surely. No, wait, that shouldn't be there. My mistake. I meant to delete this one. So this is the divergence there. So we take this one now because there's more ones. And again, it happens to be the same as our input, but we can't trust that at this point. Okay. So, and then same for the CO2, but let's stick with this simple, well, not simple, but let's stick with this input again. And now instead of building up totals, we only need to build up the total from the previous. Was tricky. We can't just assume that we'll be able to count everything because we might terminate early as well. So there's quite a few tweaks to do here. I think the first one is we're not calculating the totals every time. We're sort of running this for a total. I don't know if I want to use a for each anymore or use like a while loop instead. Let's keep it simple. I'm going to get rid of this. We've already got... No, actually, I'm going to keep all this because it generates our gamma number and our epsilon number. And for now, that's going to be the thing we're basing all this on anyway. So, but I don't want to see totals anymore. And I don't need to see the power consumption anymore. This might be the first one we fail. Let's see. So at this point, I need my input back. So let's do console.log input. Okay, and I want to iterate over that and reject all ones that aren't the most common in the first position. So now we're kind of doing a filter. And I don't need to actually get these totals again because... No, I do, because the gamma rate isn't trustworthy. So there I need to go... Let's just build it up, I suppose. So let's do inputs dot for each digits. I kind of want to do a filter. Just log each digit. Each digit's even. And then I want log all digits. I want to just check the first digit in each one, and I basically want to count them. So we're going to do a let count equals 0, and I'm going to do count plus equals digits 0. And then I need to filter all of these on whether that first digit is this. Gosh, that. Okay, so I've got a count now, console.log count. If that's greater than 6. Whoa. Oh, because I'm still reusing the count from before? Why is that count so big? Because it's using strings again. Okay, so it's 7, so if count is greater than size divided by 2, then we need to reject. If that's true, we are filter zeros, else filter ones. And this is this is where, so we have a difference in the if statement. So we've got here, where is it? If they are equal, then we keep our ones. So if the count is greater than half, so if they're the same, let's do if count is, so if there's 7 ones, more than half of them are ones, which means we want to get rid of the zeros. So I think all we need to do is put an equals here, and we should catch that equals case. So now if they're the same, if we find 6, then we should get rid of the zero still. So this is we can only use this if statement for the oxygen generator. For oxygen generator only, Joe. That's a note for myself, as I'm Joe. Now I want to filter the inputs. So input dot filter. So this is a function that can take each, well, it looks for a true or a false, and it will only return the values we return true for. So we can do if digit 0 is equal to 1, then we're going to keep it. And if it's not equal to 1, then we're going to delete it. And these need to overwrite our current inputs. Input equals. So we should end up with a new reduced input array, pending any errors. Assignment to a constant. So input, when we created input, it would never change, but now we're saying we're happy for it to change by using a let instead of a const. Ta-da! Okay. So effectively, we want all of this to continue until our inputs are only one. There's only one input left. The count needs to reset. So I think all of this needs to go inside some sort of while loop. Can I just do while input.length is greater than 1? I've written a JavaScript while loop in a little bit. I assume it needs brackets there, like an if statement. Okay, so that will run probably forever now because it'll never terminate. But that's because we're not updating this digit's value. So we need like an incrementer. So let's say this is, it's kind of like our index, but it's not really an index. And then at the end we need to increment the index equals 0. It's actually the position in the while loop we're at, so maybe that's a better way of thinking about it. And then we can do position plus plus, which will increment it by 1. Now wherever we're using this index 0, we should just be able to replace that with a position, and it should just run until it's finished. That's not the right answer. So how many times did that actually run? And it's probably because we're not resetting something. So on the first run it should be finding, let's log the, we do log the count at the end, but the count is, yeah, okay, so on the first run, let's swip those round. So we're getting, on the first run, 7, which means it should only be finding ones with 1 at the start. Next one we're getting 3, which is the number of ones in the second column, so we should only be finding numbers with a 0 in the second column. Then we're getting 3 again, so we should only be finding ones with 1 in the second column. The size of our inputs is not being updated with each run. So that's the issue. So at the start, we need to say size is equal to input dot length. And that's a constant variable again, because when we first wrote it, we thought it was never going to change. Hey, that's looking good. So that is the correct answer for the oxygen generator. Then we need to do it again for the CO2 scrubber, except this time we have to use a 0 instead. So instead of we just need to change this to an equals. So we could probably build these both up at the same time. I don't like it there. Let's do them separately. We could probably do these at the same time, but I don't want to, so I won't. So let's reset that input to read again, and in here we should just change this to a 0, and that should give us our second answer. We don't need to redeclare it, we can just overwrite it. And it break. Why does it break there? Our count is nothing. But our count should be at least 0. I imagine at this point it's probably supposed to select that one. Let's read the CO2 scrubber. Determine the least common value. It should be using our epsilon and not our gamma. So what did we do to gamma? Oh no, we're not even using, that's why, because we should be counting the, we should be using the flipped. Why do I even do that? We should be getting the least common, so we should be using 0s instead of 1s in here. Can I do that? I'm not sure if that's gonna track, but how do I get the least common value? I think I need to think very carefully about what this condition is. No. Okay. Right, so for each input, we're building up the count. So let's console.log the count there. And this is running like one more time than it should be. Size equals input.length, but the input length isn't changing either. Why did it change? No, input is changing there. Why isn't that ending when it is 1? Because I'm saying when length is greater than 1. So it shouldn't be running here. It should just be like selecting that as its end. But it seems to be running again. But what it's saying is that is the answer at the moment, so that's something to fix as well. Okay, so the counts we're getting is 7. If the count is 7, that means most of the digits are 1. If most of the digits are 1, then we care about the 0. So the least common digit is 0. Keep only the numbers with that bit in it. So if the count is greater than, so the count should be if the count is less than half. So if less than half are 1s, then we want to keep 0s. No, is that the same? So if I have 7 1s and 8 bits, not 8 bits, and I have 1, 2, how many did I have at the start? 1, 2, 10, 12. 12 digits. If I have 7 ones, if 7 is greater than 6, which it is, I want to keep all the zeros. So if 7 is greater than 6, I keep all the zeros, otherwise I keep the ones, and if they're the same, I want to keep zeros, so I do this. That is filtering on ones, but I want it to filter zeros. I don't need that note, is that right? So that's saying this is my answer, which I know isn't right because the first one should be 0. 1, 2. 7 ones. 6. So 7 ones means I should be keeping zeros because they're the least common. And then I should be keeping the 1 in the 0th position. It sounds good to me. So where is the point? I think maybe let's maybe do a log to figure out, just separate out the CO2 scrubber. Okay, so gamma. This is our CO2. So it's breaking as soon as it enters the CO2 scrubber. So something is nan. We saw before that happened when we were adding to a count that wasn't quite set up, but somewhere both the count and the input are being replaced with nan, so it's never been running. So where is that happening? Console.log of each digit, so that's this bit that's working. The count equals parseInt digits position. I've not reset the position, that's why. So as soon as it's starting, I've just not copied the bit I should have copied. So as soon as it's starting, it was starting at the position after the end of the digit from our previous run. So resetting that to 1 should mean it works. And there we go. Wow. That sucked. But we got the right answer. Now, it should terminate as soon as it finds the last one, so that should work. So we should be able to try the whole thing now. What do we actually have to do with these? We have to multiply the CO2 scrubber rating and the oxygen rating. So the oxygen rating is whatever's left in our input at this point. So const oxygen equals input 0, I guess. And we can convert that to that. So instead of gamma.join, I want input 0 join. And then down here, I should be able to do CO2 scrubber, CO2. And that should also be input. That should be okay. Then I can console.log oxygen, console.log CO2, and console.log them multiplied together times CO2. Okay, can't join them because that's a number, they don't need to be joined, I think. It's not a number, sorry, but it's already a string, so it doesn't need to be joined. 230. 230, very nice. Okay, let's try it with the whole thing, and then we can try and do a bit of a refactor, but we've only got about 10 minutes left. Whoa. Big numbers. Yes. There we go. We've got another 2 stars. I actually didn't think we would finish that one because it sounded kind of recursive-y, but I think that was good enough, is what I'll call it. What can we tidy up? I quite like all the logs and stuff happening. and the sort of way it's reducing that, so I'm not too worried about that. Really, the biggest refactor to me is this was kind of a mess. You know, I don't think I need to iterate over everything twice. I could have maybe... No, because they would have to terminate at different times. It's probably something that a recursive function would have done better with. But I don't want to write a recursive function right now. So there you go. Pretty happy with that. Bit of a mess. 100 lines of code or so. But thank you very much. Thank you very much, everybody. Thank you for coming. And I'll see you next week. Maybe at a different time. I think I have a clash. But it'll be on this YouTube channel anyway. Bye bye.